Okay, I want to give you a quick lesson on how to use the Inspire calculator to calculate definite integrals. We need a new document, of course, and it's going to be a calculator. Now, remember in this class, we're dealing strictly with radians, and so you always want to check to see if we are in radian mode, and in this case, we're not. So the easiest way probably to deal with that would be to click on the battery. That brings up this menu, hit Document Settings. Here's your angle settings right here. Change that to radians. We want to make default, and then that's going to set this to radian mode. So to get to the definite integral, notice we have a calculus menu. And we have a lot of stuff here, and we're going to be taking a look at some of this as we go along. Right now we want an integral. It comes up with a definite integral as a default, and you can obviously fill in your limits here. If you don't put limits in here, it will actually calculate an antiderivative. Now this is only true of the CAS calculator like we have in the classroom. The ones that you have, if you checked one out, are not CAS calculators, and they will only do definite integrals by numerical approximation, a lot like what we did at the beginning of the semester. Okay, so in any case, for our example in the motion notes, we want to go from 0 to 3, and our function is going to be absolute value. So where does absolute value live here? There's two ways to do that. You could type A, B, S, parentheses for absolute value, or you can go to this button right here and select this icon, and that will put your absolute value bars up here. So either way is acceptable. And also now we got to put in a trig function. So you could actually type out S-I-N, or you could go up here to trig and get it from the menu right here. Okay, let's play nice here. All right, so we got sine of t, move out of the parentheses, we've got minus t plus 1. Now you want to be careful because you want to be sure that your variable agrees with the variable you're using. In other words, we want dt here. And that's all you need to do. And when you press enter, you get your numerical approximation. All right, I'm going to try this one again just to show you the alternate ways to enter. So calculus, integral, we've got 0 up here to 3. Okay, and then I'm going to put A, B, S, and notice that it goes from italics to non-italics. That means that it actually recognizes this. Okay, parentheses, and we'll do S-I-N, parentheses, t minus t plus 1. Oops. And then dt, and then when we hit enter, you notice it reformats it so that it looks just like this, and we get, of course, the same answer. Another option is to find a website, and this is one that I use quite a bit for teaching this class, and it's called integralcalculator.com, integral-calculator.com. It's really easy to use. Once again, it will give you the option for a definite integral here, or it will calculate an antiderivative. In this case, let's just go ahead and we're going to clear this out. So we can hit clear, we can just backspace through that. And again, I'm going to put ABS for absolute value. You notice that it gave us the, right down here, gave us the double bars. Okay, sine of t minus t plus 1. Now we want to be careful because this defaults to x. If I click on this or I go to the options menu, it's going to give me the option to change that. So my variable of integration, I'm going to change to t. Now if you want to leave it as x, you can just put x in place of t. It really doesn't matter. Now these are our upper and lower bounds. Again, I can click on these spaces here and it'll take me to this menu. This will be 0 and this will be 3 right here. So you can see that it filled in everything. So this looks like the integral I want to calculate. I'm going to hit go, and it's going to think for a little bit. And it's going to do all kinds of fancy stuff. So here's the antiderivative it came up with, which when you consider the absolute value that's in there and everything, is pretty interesting. It also calculated it, I guess, a different way. And what we're really looking for is this definite integral, and here's our answer. So this should match what you got from the Inspire calculator.